Hello everyone, in this video we shall learn the types of reflected rays, okay, which is used to find the image position by spherical mirrors. Okay, so we shall learn the types. There are four types. Okay, but before we go ahead with that, I want to say some few basic, actually one basic concept. Okay, suppose let's have a concave mirror, suppose. Okay, and then we have a principal axis. No, it's not straight. Principal axis. Alright. Then let's say we have an object here. Okay. So basically there are so many rays that is coming out from a point from an object. It could be parallel to the principal axis. It could be randomly at some angle, or it could be directly coming to the pole, or it could be anywhere. So there are various rays that can come out from the point, okay, and these are infinite. But to obtain an image and its position, we at least need two rays to identify the position of the image as well as the size of the image. Alright, so we need only two rays for that. So we do not have to take all these, but there are four types of rays. From amongst these four types, we can use only two rays to identify the size and position of the image. Okay, now let's go ahead with the types of rays. Okay, so the first type of reflected rays that we can consider out of the four types that I have mentioned is this one, a ray parallel to the principal axis. Okay, so this is the principal axis. We know first we take the concave mirror, and here is the convex mirror. Now a parallel ray which is emanating from this point parallel to the principal axis is incident on this reflecting surface at this point. Now before we go ahead, let's say there's a focus, principal focus somewhere here, right, and this is the pole. This is principal axis, this is the pole. Now okay, it will bounce back and always pass through the principal focus. Okay, this is in case of concave mirror. You know why? Because we have already learned, I want to explain something. We've already learned there is a, suppose let's say a plane mirror, and then there is an incident ray coming here, then it bounces back, and we have a normal at that point. The angle of incidence is equal to the angle of reflection, right? So in this case, the normal to this point would be the imaginary line that joins this point, the point of incidence, and the center of curvature. Now okay, so we will have here, this would be the angle of incidence and this would be the angle of reflection. Now similarly, for the convex mirror, let's say let's have an object here, and let's have a parallel ray emanating from this point, and it strikes this point on the reflecting surface. Alright, also we have principal focus, center of curvature, also pole here. in this case, in case of convex, the ray which is coming parallel to the principal axis would be reflected in such a way that it appears as if it is coming from the focus behind the mirror. Okay, it is not actually originating from the focus, but it appears as though it is coming from the focus which is behind the mirror. Now, when a ray parallel to the principal axis strikes the mirrors, this is what we get in the concave mirrors, and this is what we get in convex mirror. Okay, this is the first type. Okay, even in this case, the normal connects the point center of curvature and the point of incidence, the imaginary line. This is the one. Right, so we will have the angle of incidence here and angle of reflection over here. Okay, next, the second type here we have is a ray passing through the principal focus. It says passing through the principal focus in case of concave, or directed towards the principal focus in case of convex. Let's see. Let's first take the case of concave. We have here the, let's say, the principal focus. Then we have here the center of curvature and pole here. So let's say we have a object somewhere anywhere, okay, somewhere in, okay, let's say somewhere here. Now, as we have already learned that we can take any rays that coming from the point, right? So we shall consider the ray which is passing through the principal focus and striking the reflecting surface of a concave mirror, this one. Now in this case, the reflected ray will always be parallel to the principal axis. Okay, and in this case, like we have discussed earlier, now the imaginary line joining the center of curvature and the point of incidence would be the normal, and therefore we can have here the incidence, angle of incidence here, and the angle of reflection here. Okay, this is the case that we have in concave. Now in the convex, let's say convex mirror, let's say we have a pole here, then we have the principal focus here, and then we have the center of curvature here, and we have an object somewhere here. Then let's say a ray, let's consider the ray which is directed towards the principal focus, alright, directed towards the principal focus. Okay, this is directed towards the principal focus. Now this ray is incident at this point, alright. Now it will get reflected parallel to the principal axis. Okay, now the angle is very small. Even then we can still draw the line, the imaginary line joining the center of curvature and the point of incidence is the normal. Then we will have here the angle of incidence, and we will have here the angle of reflection. Alright, okay, this is what we get in the second case, passing through the principal focus in case of concave, and directed towards the ray directed towards the principal focus in case of convex mirror. Okay, next. The third type is similar with the previous one, but not exactly the same. Here we are more focused on the center of curvature, both in case of concave and convex mirror. Now it says passing through the center of curvature in the concave mirror, and the one ray that is directed towards the center of curvature in case of convex. We shall identify the position of the principal focus and the center of curvature pole, and this is the principal axis first. Okay, fine. Let's take an object somewhere here. And then it's not necessary that we use an object for explaining this point, but then for easy understanding I'm using it. Okay, so let's take the ray of light which is passing through the center of curvature and it strikes somewhere here. Okay, it is incident at this point. Okay, let's say now this ray, in this case, it will reflect back along the same path, no deviation, because this itself, the line joining the center of curvature and the point of incidence itself, is the normal at that point for this reflecting surface. So it strikes back, it bounces back along the same path. Okay, for the convex mirror we have the principal focus here and the center of curvature somewhere here, and then this is the pole. So in this case it's the same actually. Let's say we have an object somewhere here and we consider the ray of light which is directed towards the center of curvature. So this is the center of curvature. So let's say we have a ray of light which is actually directed towards the center of curvature. Okay, it is incident at this point on the reflecting surface. Now the ray will be reflected along the same path, just as this line joining the center of curvature and the point of incidence is normal over here. Same is the case here, right? The line joining the point of incidence and the radius of curvature, center of curvature. So this itself would be the normal, alright, of the reflecting surface at this point of incidence. So it goes back along the same path. Okay, this is the third type of rays. Okay, next, the fourth point is that the ray incident, a ray incident obliquely to the principal axis. When we say obliquely, let's say we have a principal axis here, then a ray coming obliquely means a ray coming at a certain angle, not perpendicular to the principal axis. This is the principal axis, this is the ray, right? Certain angle. And this is what we know by obliquely to the principal axis, and the incident point is at the pole. Alright, so here we have the pole. Let's take this example with the concave mirror. We have a pole here, then we have the principal focus, and we have the center of curvature. Now at pole, the principal axis itself is the normal, right? Okay, normal, this line. So similarly in the convex mirror we have pole here, then the principal focus and the center of curvature. So this principal axis itself is the normal. Alright, so let's take an example. In case of a concave mirror, let's say we have an object here. Not necessarily we have to take an object, but I'm taking it, and let's say a ray of light from this point. Let's consider the ray of light which is incident at the pole. Now this is making a certain angle, so it is coming obliquely. Okay, so I'm going to erase these two. this ray of light, it will bounce back with the same angle. It will bounce back with the same angle that the incident ray had made with this. So here we have I and we have R, because this is the normal, so this is the incident point, so this is the angle of incidence, and this becomes the angle of reflections. Now these two will be same, I equal to R. Alright, and in the case of convex mirror as well, let's say we have an object somewhere here, and the incident ray is obliquely to the principal axis at the pole. It makes an angle of incidence I. Now the principal axis has become the normal, so the reflected ray will be making the same angle R. Reflected ray will be making the same angle. So even in this case, I equal to R. Now we have studied 4 types of reflected rays. Now from these 4 types of reflected rays, only 2 is enough for clarity and easy understanding of ray diagrams, and very clear and concise. Alright, so in the further videos, further tutorial, we will learn the various ray diagrams, both the concave mirror and as well as the convex mirror. Thank you.